One last example for you. In this one, we're going to apply the inverse linear function. Here we've got Skylar and Cameron riding a paddle boat that they've rented at a state park. It costs $15 plus $4 for each hour it's used. The function c of x equals 4x plus 15 represents the total cost, c of x, for x hours. So c of x is your money, x is your time. First thing we want to do is determine the inverse function. So we take c of x equals 4x plus 15, which is going to be our original equation, the standard rate of $15 plus the $4 per hour. Replace c of x with y just like you would f of x. Interchange the x and y. Subtract 15 from both sides, divide by 4 on each side, and simplify. So we get that x minus 15 over 4 is equal to the c inverse of x. Now we need to interpret the inverse function. Interpret x and c inverse of x in the context of the situation. X is the total cost of renting the paddle boat, and c inverse of x is the number of hours that Skylar and Cameron used the paddle boat. So remember, originally y was the total cost and x was the number of hours. Since we flipped them around, it is now flipped to the meaning of the problem as well. Now, why would you do this? A good example of why you would want to do this inverse is, let's say Skylar and Cameron have $35 to rent the paddle boat. How long can they rent it? Right? They want to know, how many hours can we get out of this if we only have $35? So instead of using c of x equals 4x plus 15, right, and plugging in different times and seeing which one comes up to be 35 or whatever, they're just going to use this inverse function. They're going to plug in 35 for x, right? 35 minus 15 divided by 4, and they see that they can get 5 hours of time on their paddle boat. So this is one way of being able to kind of work backwards on a problem if you are given different information.